Okay, ladies and gentlemen, on this next question, we're asked to sketch a couple graphs, the natural log of x minus 2, and then the natural log of x minus 2. Big difference here. This minus 2 does not go with the x, and this one does. So basically, this is ultimately going to be shifting my original graph down 2 units. This is going to be shifting my original graph to the right 2 units. But we can see all that on a calculator. So let's do the first graph, okay? Come here with me, make sure my calculator's on, and y equals, and I'm going to type in the natural log of x. I'm going to close parens, and then I'm going to type minus 2. Okay, that's my first graph. And when I do, you see the picture that I have, okay? What's actually happening, and I'll show you on my drawing, what's actually happening here is the graph is asymptotic to the x-axis, to the y-axis, so our asymptote would be the line x equals 0, and then the graph hits the x-axis somewhere and starts climbing above it. Okay, what's the domain? Well, the domain would be all values of x that are bigger than 0. And the equation of the vertical asymptote, the equation of the y-axis, is x equals 0. Now, if I want to do this second graph, all right, y equals the natural log of the quantity x minus 2, this time my natural log graph is being shifted to the right. Watch what happens when I type it in. All right, y equals, let me clear out the garbage I have in there. And now let me type in natural log, it's already given me one paren. I do x minus 2, and then I group it. Okay? So I have the natural log of the quantity x minus 2, and I hit graph. Okay, now, what's happening here looks just kind of weird on our calculator. It's like, what's going on here? You know? All right? Kind of like, who is that on the old show, Will and Grace? Karen, you know? What's happening here, honey? You know, what's going on here? I used to love that when she would pick on Grace about her clothes. But anyhow, so I'm going to ask you, what's going on here, honey? Well, I'll tell you. What's happening is the graph is just dropping off, okay? And where it's dropping off is with respect to the line x equals 2. In fact, that's where the asymptote's occurring. If you hit, let me try if this helps you see it better. If I hit zoom in, okay, if I hit zoom 2 and hit enter, yeah, it does help you see it a little bit better in terms of the fact that, you know, what it's doing, and again, if I hit trace, might help us see things a little bit better if I can make the graph move over a little bit. Okay, I'm trying to get the spider on the screen for you. Okay, see where the spider, it took me forever to get that spider to come up to where you could see it. That's because it was dropped all the way down, but it was hovering against the line x equals 2. And then now if I continue, you can see what's happening is my graph is then rising above the x-axis, and so on and so on. So basically what we have to pay attention to is when we're drawing this picture, the most important thing to draw in is the line x equals 2, because that is my vertical, I'll call it VA, you know, not the state of Virginia, but vertical asymptote. And then my curve, you know, goes like this. Now, I didn't cross the x-axis at an exact place. I could have always used the 0 function to find that out. But I'm really not even that interested in that. What I'm truly interested in is knowing that you know that this is the equation of the vertical asymptote, x equals 2, It's where the graph seems to just drop off into an abyss, okay? That's why it took us so long to get our spider to come back up. And actually, let's see, we can almost tell where the graph, like right about there is where the graph finally crosses the x-axis and goes over. But again, I don't care so much about that as I do you knowing this and you knowing the domain. The domain is the set of all real numbers greater than 2. And the reason you don't put a bracket on 2 is because 2 is a vertical asymptote. It never reaches the x value of 2. It gets close to it, but never actually includes it. And again, if you wanted the perfect location where this is crossing, you've already been taught the 0 function. You could actually use the 0 function and determine the perfect x-intercept. That's not what I was worried about here. I was worried about two things in this problem. You knowing how to enter this into your calculator and you understanding the ramification of the vertical asymptote and how that affects domain. And we're done.